Okay, so let's start. Medyo marami yung topic, no? Kasi there are two topics for this week, so which are still included for your midterm exam. So the first one would be the introduction for higher order differential equations, and then the other one would be the solution of homogeneous higher order differential equations. So to start with, by the way, we are all done with the different methods in finding the solution of a first order differential equation. So together with the applications or some of the application of first order differential equation. So this time around, so we'll have the higher order differential equation. So we'll first introduce what is a higher order differential equation. So what are the methods that we have? So in solving higher order, and then we'll have the first. Okay, so we'll have the first method in solving higher order differential equations. So for higher order differential equations, so they are divided into two types only. Okay, so there are two types of higher order differential equation. So one is homogeneous equation, the other is the non-homogeneous equation. So homogeneous equation is different from the homogeneous equation that we know for first order. So that is different. Although the meaning would be the same, but the perception for the homogeneous equation under higher order differential equation is that the uh, the function and its derivative. Okay, so if a given differential equation involves a function and its derivative only, okay, so that is considered homogeneous. However, if a function or if a certain equation involves a certain function plus the derivatives plus another function, therefore that is considered as a non-homogeneous differential equation. So what do I mean? So for example, on the given equation shown on your screen, so a sub n of x and then d raised to n or the n derivative, so with respect to x, and then the derivative decreases until it would just be multiplied to the y function, and then that would be equal to 0. So in those case, that is considered as homogeneous. Okay. Example of homogeneous, let's say we have 4y triple prime minus 2y double prime plus 2y minus y is equal to 0. So in this case, so it involves only a function y together with its derivatives, okay, up to the third derivative. Therefore, that is considered as homogeneous. However, if a certain homogeneous equation and then there is another case of function which is added on the equation, so that makes it non-homogeneous. So for example, if I would have the same or let's say a different minus y, then it's equal to sine x. Okay. So in here, so the one on the left-hand side, so it would appear that it is a homogeneous equation. However, with the inclusion of sine x on the differential equation, it already makes it a non-homogeneous equation. So that's the only difference. So as long as we have a g of x, so which is included on our differential equation, so that g of x could be a constant. So pwede rin kasi a constant. It could be a trigo function. Okay, it could be an exponential function, or it could be a logarithmic function. Okay, or transcendental function, and or any other functions. Okay? So that is considered as a non-homogeneous differential equation. So those things that involves only zero. Okay, so if g of x is equal to zero, so that is the one that makes it homogeneous. But if g of x is anything other than zero, okay, so whether it is already on the right-hand side or it's on the left-hand side, because there are cases now, for example, if I would have y double prime minus y plus 1 is equal to 0. So y double prime minus 1 plus 1 is equals to 0. This one is non-homogeneous. Okay, so because of the presence of the positive 1. So our g of x there is equivalent to a negative 1 if I'm going to transpose the right-hand side. Okay, so that is on how to distinguish whether that is homogeneous or that would be a non-homogeneous differential equation. So when we say higher order, so from the term itself, so it involves a differential equation whose derivative is more than one, okay, or whose derivative is two or more. So as you can see here on the given example, so we have a third derivative, so that makes it a higher order differential equation. So again, in higher order differential equations, uh, if or the number or the order of the differential equation so will correspond to the number of solutions of the differential equation. As we have mentioned before, on a first order differential equation, there's only one solution. Okay, so there is only one solution for a first order differential equation. However, if the order of the differential equation is a second order, so that means there are two solutions. Third order, there are three solutions. So the order of the differential equation so will correspond to the number of solutions of the differential equation. Okay, so that's the difference between the homogeneous and the non-homogeneous equation. Next is let's try to, or how do we verify so whether a given differential or a given solution is a solution of the differential equation. So just like what we did on the first order differential equation, so we just need to take the derivative of the given solution and then substitute it to the original differential equation. So once, okay, so it satisfies our original differential equation, therefore that is a general solution of a differential equation. So, ganun pa rin. So, parang kamukha lang nung verification of a solution. So, derive, and then afterwards, substitute. Pag nag-equate siya, therefore, that is a solution of a differential equation. So, ngayon, let's proceed with the characteristic of the solution of a differential equation. So, before tayo mag-proceed dun sa mga examples, so let's try to take a look at the characteristics. Okay, so characteristic of the solution of a differential equation. So how do I know whether yung mga sets of solution na to are really a solution without substituting it to the original differential equation? So let's have some properties here. I'll be talking about that one. Let's say we have a second order. So I'm talking about a second order differential equation. So the standard form of a second order differential equation looks like this. So let's say a or a second order homogeneous equation. Ay double prime plus b y prime plus cy is equals to 0. So this is a standard form of a higher order differential equation. So meron tayong second derivative, and then a, b, and c are the coefficient. The coefficient of a differential equation. Coefficient of a differential equation. So it says here that if ay double prime plus by prime plus cy is equal to 0, then therefore, that is a solution of a differential equation. So for example, meron ako, one of the solution I am guessing that it is a function of x. So let's say it's h of x. So I am assuming that y is equals to h of x. So wherein h of x is a solution of the differential equation. So kung isa-substitute ko yan, so y prime So, di ba yung verification, y prime, so that would be h of x. Tapos y double prime would be h double prime of x. So pag sinabstitute ko yan, so I'll just have, so y double prime is h double prime of x, and then plus b, h prime of x, then plus c is h of y, is equals to 0. As you can see here, this given equation is the same as the one above. Okay, so nagkabaligtad lang. So instead of y, it becomes an h of x. Okay, pero kung titignan mo, they are still the same. Okay, so iba lang yung variable na ginamit natin. Pero it only shows here that y is equals to h of x is really a solution of the given differential equation. Okay, so kasi nga, that is still equal to 0. What if now, let's say h of x is a solution of a differential equation, a constant dun sa solution ko. So, di ba? Ang solution natin is h of x. Tapos nag-multiply ako ng constant. A constant multiplied it to the solution of the differential equation. So will it still be a solution of the differential equation? Solution pa ba siya? Okay. So let's try to see. So ngayon, so sabi nga natin kanina, so derive lang natin. So y prime is k h prime of x. And then y double prime is k h double prime of x. So substitute natin din sa original equation. So we'll have a k h double prime of x, then plus b k h prime of x, then plus c k h of x is equals to 0. As you can see here, k is a factor. Tama? So factoring out k, so we'll yield to a h double prime of x h prime of x plus c h of x is equal to 0. So this is equal to 0. So k times 0, it's to 0. So 0 is equal to 0. So therefore, if we are given a solution and then nag-multiply lang tayo ng constant dun sa solution na yon, that solution is still a solution of the differential equation. Okay? So basta nag-multiply tayo ng constant sa isang solution ng differential equation, it is still a solution of the differential equation. Eh, what if I would have, let's say, sabi natin kanina nga na, let's say one of the solution is h of x. Tapos, kasi di ba ang solution ng differential equation na higher order is more than 1. So let's say ang first solution ko is h of x. Tapos ang second solution ko is g of x. Okay, so those are the two solutions of the differential equation. Hello. Oh. Can you see her? Okay. Yeah, disconnect ako. Sige. Can you still hear me? Okay, good. Medyo nadidelay na. So going back. So sabi ko nga, so let's say h of x is a solution. G of x is another solution. Kapag pinag-add mo sila, will it still be a solution of the differential equation? So let's say, i-add ko sila, h of x and g of x. So pag dinerive ko yan, lolo ko na naman ang connection ko. Okay, going back. So derive prime of x. Then y double prime would be equal to h double prime of x plus g double prime of x. Hello. Last na lang, ayoko na. Okay. Now that we have the second derivative, so kung substitute natin siya dun sa kanina, so magkakaroon tayo ng A multiplied it with H double prime of X plus G double prime of X plus B H prime of X plus G prime of X and then plus C H of X plus G of X is equals to 0. So now, so we could distribute A, so H double prime of X, plus B H prime of X, plus C H of X, then plus A G double prime of X, plus B G prime of X, plus C G of X is equals to 0. So from here then, so we can say that this one is equivalent to 0. This another function. Oh my God. Hello. Hello.
Hello, sir.
Ay, hindi na kaya. Okay, so ngayon, so we have seen na kapag yung dalawang solution natin, if we're going to add them to forming a single solution, then those are still a solution of the differential equation. Okay, so yun yung tinatawag nating superposition theorem. So the solution of the homogeneous n-order differential equation is a linear combination of the solutions. So for example, yung y1 of x natin, y1 of x is the first solution, y2 of x is the second solution, and then y-kth of x is the kth solution. So pag pinag-add-add mo yan, so forming the general solution, that general solution is a solution of a differential equation. Okay? So, ang ano kasi dyan is parang, for example, you got the first solution. So, substitute mo siya dun sa original, mag-equate yan. Kunin mo yung dalawa or yung pangalawa naman, i-substitute mo rin siya dun sa given differential equation, it is still a solution. Pero kapag pinag-add mo yung dalawang solution, okay, so that is still a solution of a differential equation. So that is what we are referring for the superposition principle. Okay, so the addition of a solutions of a differential equation will form the general solution. And that general solution, of course, is a solution of the given differential equations. Next, another characteristic of the higher order differential equation is that they are linearly independent with each other. So what do I mean by linear? They are linearly independent. Okay, meron tayong definition dito. The linearly dependent and linearly independent solutions. Okay, so linear dependence and independence. So a set of functions, so f1 of x up to fn of x, are said to be linearly dependent on an interval I if there exist constants. So c1, c2 up to c sub n, given that all of those constants are not zero. Okay, not all of those are zero, such that if I am going to multiply those constants or C1 to the function and then adding all of those, so it will become equal to zero. So if it is equal to zero, then those functions are linearly dependent. If it is not equal to zero, those are linearly independent. Okay, so yun yung difference ng linear dependence and linear independence. So to better understand that, so let's have an example. Okay, so let's say meron tayong tatlong functions. So we have the f of 1, which is x. The other f of 2 is x squared. F of 3 of x is 4x minus 3x squared. Those are the three functions. So we are going to test now so whether these three functions are linearly dependent with each other. So paano natin iti-test yun? So using the superposition theorem, so sabi natin, so attach tayo ng C1, so multiplied it with our first function which is x. Tapos plus C2, multiply natin siya sa ating next function, so which is x squared. Then plus C3, multiply tayo ng 4x minus 3x squared, and then that would be equal to 0. So ngayon, para matest natin ito, so whether this is linearly dependent or not, so maghahanap tayo ng C1, C2, C3. So constant yan. Ano ang mga value ng C1, C2, and C3 na kapag minultiply ko sila, okay, tapos pinerform ko yung algebraic operation dito, ang sagot would be equal to 0. So meron ba tayong values ng C1, C2, C3? Okay, hindi pwedeng lahat 0 Kasi kung ang C1, C2, C3, 0 yan, so definitely magzi-0 lahat. It will be equal to 0. Pero ano yung value ng C1, C2, and C3? Na kapag minultiply ko siya dito sa equation na to, ang sagot will be 0. So negative 4, 3, and 1. Ano daw? Negative 4, 3, and 1. So let's try to see. So C1 is negative 4x. C2 is 3x squared. Tapos C3 is 1. No? So that will just make it 4x, then minus 3x squared is equal to 0. So from here, so negative 4 plus 4, so that would cancel out. So 3x squared minus 3x squared would cancel out as well. So therefore, 0 is equal to 0. So therefore, those functions are linearly dependent with each other. Dependent. So those are linearly dependent. So very good. Let's have another example. So let's say meron tayong C1 which is 5. Let's say, sulat ko na, 5 C1. Tapos plus C2 cosine squared x plus C3 sine squared x equals to 0. So what value of C1, C2, and C3 so that it will make it 0? Actually, marami yung possible na sagot, no? Pero just give one only. So pag yung isa, naging 0 na siya, therefore that is already linearly dependent. Nag-iisip? Wala. Bigyan ko kayo. Example, C1 is positive 1. C2 is negative 5. C3 is negative 5. So let's substitute. So 5 times 1 minus 5 cosine squared x minus 5 sine squared x is equals to 0. So I just have 5. Then common ang 5. So factor out ko ang 5. I'll have cosine squared x plus sine squared x equals to 0. So 5 minus 5 cosine squared x plus sine squared x, that is 1. So equals to 0. So therefore, 5 minus 5, 0. So therefore, those are linearly dependent. Di ba? So yung C1, C2, C3, so sometimes, hindi siya right away na makakancel out. But sometimes you need to use some identities. Okay? So para masabi natin that those are linearly dependent or independent. Mahirap ba? Kasi wala tayong solution dito. It's just logic. Okay? So wala tayong exact method. We just need to think. So what combinations of C, okay, or arbitrary constants that would make it 0? Pero there are cases naman na kahit anong gawin mo, okay, wala talagang combination. Example, this one. So meron tayong C1, 1 plus x, plus C2x, plus C3, x squared is equals to 0. So kasi C could only be 0, no? So could only be 0. Or sorry, C could only be constant. So pwede naman kasing ano, may dalawang 0, tapos yung isa constant. Kaya lang ang problema dito, so we could not, so pwede natin kasing gawin na 0 yung C2, 0 din yung C3. Ang problema, kahit anong i-multiply mo dito, may matitira at may matitirang 1. Okay? So pwedeng mag-multiply ako ng negative 1 dito, o tapos ito positive 1. Ang matitira is negative 1 minus x plus x. So cancel out ang x. Kaya lang may matitirang negative 1 pa rin. Okay? So actually, in reality, okay, so for this particular example, so there is no combination. Okay, so there is no, or there are no values. There are no values for C. Okay, so that would make it the equation equal to 0. So in this particular example then, so ang sagot natin nun, so this is linearly independent. So it is linearly independent. Those three functions are linearly independent. Okay, so that is one method. Okay, so that is one method in determining so whether those given sets of functions are dependent or independent. If there is a combination of arbitrary constants na it would make it 0, that is linearly dependent. Pero kung wala, okay, so walang combinations of C or of constants that would make it equal to 0, therefore that is linearly independent. Sir, wala bang ano mas madali? Okay, na there is a method. Okay, so instead of just thinking out of nowhere, so kung ano yung value ng C1, C2, C3, so that would make it linearly dependent or not. So actually meron naman. Okay. So ang tawag natin doon, it's the Wronskian method. So Wronskian method so can be used to determine so whether the set of functions are dependent or independent with each other. So how do we do that? So ang formula natin ganito lang. So we are just going to determine or evaluate yung determinant natin. So lagay lang natin yung functions natin. So let's say the first function f1 of x. Tapos yung pangalawa would be f2 of x. So ngayon gagawa tayo ng matrix. Gagawa tayo ng square matrix na kung dalawa yung functions natin, so 2 by 2 matrix siya. Kung tatlo yung functions natin, 3 by 3 matrix siya nun. Tapos, since ang given lang natin are the two functions, so para makuha natin yung second row, so i-derive lang natin. So f1 prime of x, tapos yung isa, f2 prime of x. So that is for a 2 by 2. So paano kung 3 by 3? So f1 of x, f2 of x, f3 of x. So pag tatlo, edi 3 by 3. So f1 prime of x, prime. Tapos f1 double prime of x. So f2 prime of x, f2 double prime of x. Tapos f3 prime of x, f3 double prime of x. So ngayon, if w is equals to 0, that is linearly dependent. If w is not equal to 0, okay, so that is linearly independent. Na-cover nyo yung determinants during your senior high. Or nag-Kramer's rule kayo, something like that. Hindi. Okay. Sa bagay, hindi. Madali lang naman. So how do we evaluate? Okay. So let's say meron akong f1 of x, so which is, gaya ako ng isa. Hula na lang ako. X squared. Tapos yung f2 of x natin is 2x. So ngayon, I'm going to determine whether those two functions are linearly dependent or linearly independent with each other. So sabi natin kanina, so gawin lang natin yung matrix. So x squared yung una, pangalawa would be 2x. Tapos, x squared would be, derive mo lang. So 2x, so yung isa would be 2. And then sa determinants, okay? So in evaluating this one, pag 2 by 2, simple lang siya. So that would be the downward minus the upward. The product of the downward, so minus, okay? So product of the downward minus product of the upward. So this one would become, W would be equal to, so downward would be x squared, so times 2. Then minus product of the upward, so we'll have 2x times 2x. So which is 2x squared minus 4x squared. So which is negative 2x squared. So as you can see here, W is not equal to 0. So therefore, it is linearly independent. So ganun lang kadali. Diba? Try natin i-solve yung kanina. Yung kanina kasi, di ba, nag-solve tayo ng, i-add ko ulit. Kaya lang this time, we're going to use Wronskian. So ang sagot natin kanina dito, this is linearly dependent, di ba? So therefore, ang Wronskian natin dito, that should be equal to 0. So how do we do this? So W, so yung Wronskian natin, so we're going to write down, so x, tapos x squared, tapos we'll have 4x minus 3x squared, and then derivative ng x is 1. 1 would be 0. X squared is 2x, tapos I'll have 2. So 4x, that would be 4 minus 6x. Tapos negative 6. So ngayon, since 3 by 3 na to, so para hindi tayo malito, so ang ginagawa natin is nire-write natin yung first two columns. Okay, so kasi magda-downward minus upward tayo eh. So rewrite ko lang. So that would be x, yung first two columns, x, 1, and 0. Tapos x squared, 2x, and then 2. So ang mangyayari niyan, so downward. So product ng downward. So ang product ng downward niyan would be ito. Okay. Anyway, so ito siya niyan. Yung tatlo. Tapos yung sa taas naman. This 1, 2, 5. So ang gagawin natin would be W then would be sum of the products. So yung nakababa, so multiply mo na lahat. So we'll have x times 2x times negative 6. Tapos plus, yung pangalawang linya, So x squared times 4 minus 6x times 0. Then plus 4x minus 3x squared times 1 times 2. So downward lahat yun, no? So tapos minus upward lahat. So we'll have 0, so times 2x, so times 4x minus 3x squared. Tapos plus 2 times 4 minus 6x times x. Then plus negative 6 times 1 times x squared. So W then would be equal to, so may 0 to, so 0 na yon. So 0 na rin to. So this one would be, so 2x, so negative 12x squared. Then plus, so 2 times 4, so 8x minus 2 times 3, so we'll have 6x squared. Okay, so tapos we'll have 2 times 4 times x, so plus 8x. Then minus 2 times 6, so 12x squared. Then I'll have negative, oh sorry, nakalimutan ko, may negative pala doon. Negative 6x. So, hindi tayo malito. So minus, so dito naman, so I'll have 8x, then minus 12x squared, and I'll have negative 6x squared. So as you can see here, so we'll have negative 12x squared minus negative, and 8x minus 8x, negative 6x minus. So therefore, W is equals to 0. Therefore, this is linearly dependent. So kung ayaw niyong mag-multiply ng ng mga maramihan, so pwede kayong mag-substitute. For example, no? Off ko siya para makita yung buo. Yan. Example, when, kasi meron tayong original na na square. So let's say gawin ko when x is equals to 1. So para puro numero siya nun. So yung x magiging 1. So 1 is already 1, then 0. X squared. So that is 1 squared. So 1 pa rin. 2 times 1 is 2. Then 2. Then 4 times 1 minus 3 times 1. So it's short for minus 1. That is 1. Tapos 4 minus 6. That is negative 2. Tapos meron akong negative 6. So rewrite mo lang 1, 1, 0. Tapos 1, 2, 2. So W mo nun, yan. 1 times 2 times negative 6, negative 12. 1 times negative 2 times 0, so plus 0. 1 plus 1 times 1 times 2. So, nagigets naman natin, ha? So ito yung una, pangalawa, tatlo. So plus 2. Plus minus. Sa taas naman. This one, this one, this one. We'll have 0, This would be 0, and then negative 4, and then I'll have negative 6. So W then would be negative 10 minus negative 10. So W is still 0. So pares lang. Kaya lang ito, mas madali kasi hindi ka na nagmumultiply ng marami. Okay, so that is Wronskian. So should we solve the other one? So pwede rin yung isa, no? Let's say yung pangalawa. So ito, solve ko na lang na magsa-substitute ako, no? So this is W. I'll have 5 cosine squared x sine squared x. So derivative ng 5 is 0. Tapos 0 yun. Cosine squared would be 2 cosine x sine x. Negative, no? Tapos ang sine squared will be 2 sine x cosine x. Kaya lang, ang derivative ng cosine x, separate ko. So, sine x cosine x. So that would be, so sine x, so derivative ng cosine would be sine x. Tapos plus cosine x, derivative ng sine x would be negative cosine x. So in short, I'll have sine squared x minus cosine squared x. Or magkakaroon tayo ng negative 2 sine squared x minus cosine squared x. Tapos yung isa, 2 times sine squared x minus cosine squared x. So ngayon, so since it involves cosine trigo functions, no? So mag-assume ako ng, let's say, x is equals to 0. So di ba kapag cosine 0, that is 1. Sine 0 is 0. Okay? So if x is 0, so W then would be equal to 5, so 0, 0. So cosine squared, so cosine 0 is 1. 1 squared is 1. So sine 0 is 0. So basta meron siyang sine, it's already 0. So 0 din siya dun sa 2 sine x. Pero ito, ang sine is 0, pero cosine would be 1. So 1 squared is negative 1. Negative 1 times negative 2, that would be positive 2. And then the last one is sine is 0, so cosine is negative 1. So 2 times negative 1 would be negative 2. Ito, obviously, no? Kasi ang buong row mo, it's already 0. So kahit ulitin mo to, so 5, 0, 0, 1, 0, 2. So yung downward mo, so what can you see? So W mo would be 5, 0, negative 2, 0. 1, 0, 0, 0. 0, 0, 2, 0. Minus 0, 0, 0, 0. 2, 0, 5, 0. Negative 2, 0, 1, 0. Therefore, W is equals to 0. This is linearly dependent. Dependent. So kamukha siya nung kanina. So linearly dependent. Question so far? So tapos na tayo dun sa introduction. So the introduction would be the first one is yung superposition theorem. Sabi natin, ang isang solution, pag minultiply mo siya ng constant, solution pa rin siya. So meron kang dalawang solution, pag pinag-add mo sila, solution pa rin siya. Okay, so that is one of the characteristics on the solution of the differential equation. Then ang pangalawa, we've determined so whether those wala tayong mabuo or makakuha ng value ng C na mag-equal siya sa 0, so making it independent. So ang mas madali would be the Wronskian method. So gumagamit tayo ng determinants. If the determinant is equal to 0, that is linearly dependent. If the determinant is greater than or other than 0, so that is linearly independent. Ang tanong, sir, anong sense nung linearly dependent at saka linearly independent? Okay? So this is just our summary here. The solutions of a higher order differential equation are linearly independent. So para ma-check mo na, for example, tama ba yung sagot mo? So you could check their linear independence. So if all of the solutions are linearly independent with each other, therefore, that is a solution of a differential equation. If a set of solutions, okay, are linearly dependent with each other, therefore, those are not a solution of a differential equation. Okay, so that is the idea why we are getting the linear independence or dependence of the solution. Kasi nga, yung mga solutions or set of solutions ng differential equations natin are linearly independent with each other. Okay? So that one, so which proceeds, okay, so dun sa solution, so punta na tayo dun sa solution of second order differential equation. So, sabi ko nga kanina, so ang general format natin is yung A y double prime plus by prime plus c is equals to 0. So ngayon, for example, magbigay ako ng second order. So y double prime plus 5y prime plus 6y is equals to 0. So this is a second order homogeneous differential equation. So ngayon, sabi natin kanina, so para malaman mo na solution nga yun, maybe derive mo siya hanggang second order or second derivative. Then pag nag-equation sa 0, that is already a solution of a differential equation. So usually, para mag-equal sa 0 to, kasi for example, let's say ang solution ko is x squared. Isa, solution is x squared. Just simply x squared. So kung solution yan, kung differential equation, pwede kunin ko yung y prime. So y prime yan is 2x. Tapos y double prime will be 2. Pag sinubstitute ko yan, that would become 2 plus 10x. Okay, so 5 times 2x is 10x. Then plus 6 times x squared will be 6x squared. It's equals to 0. Kaya lang, as you can see here, this is not equal to 0. So kasi nga, yung variable natin, nag-iba-iba yung degree niya. Diba? Nung dinerive ko siya, from second degree, naging first degree, naging 0 degree. Okay? So kaya, usually, sa mga higher order, hindi solution yung mga algebraic functions. What do you think? Anong function na kapag derive mo siya, hindi man nagbabago yung order niya? Anong function yon? Kahit i-derive mo siya, hindi nagbabago yung order niya. Oh, very good. Exponential. Okay, so Noel and Jonard. So exponential. That is si Earl. So that is what is good with ano, no, na hindi siya nagbabago. Kaya like for example, magtansya ako dito na ang isang solution ko would be, let's say, e raised to, ano kaya maganda? Let's say, -2. Manghula ako. Y e raised to -2x. So, sabihin ko, that is a solution of the differential equation. So, ang gawin natin, derive natin yan. So, y prime is e raised to, or -2 e raised to -2x. Tama? So, y double prime would be +4 e raised to -2x. So, pag sinabstitute ko yan, y double prime is 4 e raised to -2x. Tapos plus 5, y prime is -2 e raised to -2x. Then plus 6 e raised to -2x equals to 0. So 4 e raised to -2x minus 10 e raised to -2x plus 6 e raised to -2x equals to 0. So 4 plus 6 is 10. 10 minus 10, 0. Di ba? Ibig sabihin, nakuha na natin yung isang solution. So ang unang solution ng differential equation na yan is e raised to -2x. Kaya lang, sinasabi natin kanina na kapag kung ano yung order ng differential equation, ganun karami yung solution niya. Sa tingin nyo, ano yung next solution? Ano yung pangalawang solution? Hirap naman siya, pinahuhula mo sa akin. Wala bang method dyan? Okay. I-derive natin. Okay. So actually, ang pangalawang solusyon natin is e raised to -3x. Okay, so e raised to -3x. Sir, paano nakuha yun? Siyempre, nag-lag na naman ako, no? Sa internet na to. Anyway. So, assuming nasabi natin, halos ano naman yung ano yung mga solution, puro exponential. Gawin ko siyang, let's say, e raised to mx. Variable siya. E raised to mx. So, ang first derivative niyan, so would be e raised to, or m e raised to mx. Tapos y double prime would be m squared e raised to mx. So pag sinabstitute ko siya dun sa original equation, so y double prime, so m squared e raised to mx, tapos plus 4m e raised to mx, sorry, hindi siya 4, it's 5. So 5 tapos plus 6 e raised to mx is equals to 0. So from here, so we can factor out e raised to mx. So matitira would be m squared plus 5m plus 6. So remember, yung m natin dito, that is our, that's the coefficient nung sa exponent natin. No? So from here, so since product na yan, so we can make that m squared plus 5m plus 6 is equal to 0. So we can factor this out. So para makuha natin yung m. So ang factor niya would be, Hindi tayo manghula. Ito, dinidrive natin yung formula. So, M and M. So, ang 6, we have 2 and 3. So, that would become plus and plus. So, kakaroon tayo ng M plus 2 and M plus 3. So, nung mapapansin nyo, so M1 would be negative 2. Ang M2 natin would be negative 3. So, kaya, yun yung naging solution natin. Okay? So, di ba, ang Y1 natin nun is actually equal to e raised to M1x. Then, ang Y2 natin would be e raised to M sub 2x. So, ngayon, yun yung dalawang solutions natin. E is equals to M1x, and then Y2 is equals to e raised to M2x. So, anong kinukuha natin? So, kinukuha lang natin yung roots. Okay? Anong mapapansin nyo dito? Itong M squared 5M plus 6. It's the same as this, di ba? So, yung Y double prime naging M squared. Tapos, yung Y prime naging M. Tapos, yung 6Y naging 6. Equal to 0. So, transform mo lang siya ng ganyan, and then factor out mo yan, makakakuha ka ng dalawang factor. So, kapag ang factor mo, those are distinct roots. So, kapag ang factor mo are distinct roots, that means we have M1 and M2. So, ang solution niya, so di ba using the superposition theorem, so pwede nating ipag-add yung dalawang solution. That is e raised to M1x plus e raised to M2x. And then, di ba, kapag nag-multiply tayo ng constant, that would still be a solution. So, meron tayong arbitrary constant C1 at saka yung second arbitrary constant C2 natin. So, forming our general formula. So, na kapag distinct roots, yung M1 is not the same as M2. Okay, so kunin mo lang yung roots and then substitute mo dito. So, on our case, so ang sagot niya nun, so that would be, general solution natin is y is equals to C1 e raised to negative 2x plus C2 e raised to negative 3x. So, that is our final answer. Okay, or that's the general solution. So, for the given second order differential equation. So, hindi tayo manghuhula. Okay? So, magpa-factor out tayo. Question? Wala. Okay, so yun yung first example natin, no? So, this is our first example. So, pangalawang example. So, what is ito yung second order? Y double prime plus 2y plus 2y prime plus 5y is equals to 0. So, di ba ang sabi ko kanina, so para ma-resolve yung ganito, so yung second derivative, palitan mo lang ng 2. Okay? Kung ano yung derivative, yun yung power niya. Then plus 2m, then plus 5 is equal to 0. So can we factor this out? So may factor ba yung equation na to? M squared plus 2m plus 5 is equals to 0. Meron? Wala? Wala. Kasi 5, ang factor na lang is 5 and 1. So there's no way na makuha natin yung 2m. So since quadratic ito, so we can use the quadratic formula. So m is equals to negative b. So ang b natin is 2. So negative 2 plus and minus the square root of Quadratic equation, quadratic formula, I mean. B squared. So 2 square minus 4AC. So 4, A is 1, C is 5. Divide it with 2A. A is 1. So M then would be equal to negative 2. So plus or minus the square root of 4 minus 20. Negative 16. Over 2. Kaya lang, the square root of negative 16, that is negative 2 plus or minus imaginary yun, di ba? Tama. So square root ng 16 is 4. Tapos yung negative 1 is the same as I. Then divide it with 2. So ang M natin nun would be, so negative 2 over 2 is negative 1 plus or minus 2I. So yan ang roots natin. Ang M1 natin is negative 1 plus 2I. So ang pangalawang roots natin would be positive 1 or negative 1 minus 2I. So yung kung isa-substitute natin to dun sa formula kanina, so y would be equal to C1 e raised to, ayan, negative 1 plus 2I times x, then plus C2 e raised to negative 1 minus 2I times x. So kaya lang, we don't want na ma-involve yung imaginary. Okay? So gusto natin real functions ang meron tayo. So ngayon, i-derive natin ang formula. So let's say ang M natin would be an imaginary number, di ba? So alpha plus or minus beta I. So yung alpha natin so would correspond to the real part. Tapos ang beta natin so would correspond to the imaginary part. So ayan, sabi natin kanina, so kung ganyan ang solution niya, so y would be equal to C1, so e raised to alpha plus beta I times x, and plus C2 e raised to alpha minus naman, so beta I times x. Tapos using the properties nung sa exponential or sa algebraic lang ng exponent. So C1 would be the same as e raised to alpha x, tapos e raised to beta I x. Pangalawa, C2 would be e raised to alpha x, e raised to negative beta I x. Okay. So y then would be equal to, so pwede natin i-factor out yung alpha x. So making it C1 e raised to beta ix at saka plus C2 e raised to negative beta ix. Kaya lang sa exponential, okay, so it involving Euler function. So meron tayong ginagamit na identity na e raised to ix. This is the same as cosine x. Okay? So plus I sine x. So that's an Euler function. Parehas lang yan. Cosine x plus I sine x. So kung i-substitute natin yan, so e alpha x, so C1, so instead na ix, or just simply x, meron siyang coefficient na beta. So ang lalagay natin doon, so C1 cosine, okay, so C1 cosine beta x, and then plus I sine beta x. So pangalawa, plus C2, this time we have cosine negative beta x, tapos plus I sine negative beta x. So C1 cosine beta x, na-distribute ko na. then plus C1 I sine beta x. And then this one, diba? Yung negative cosine of a negative angle is the same as the angle itself, yung positive. Okay? So properties ng cosine. So this one is the same as ito. This is equal to cosine beta x as well. Etong sine negative beta x naman, that is the same as negative sine beta x. So, pag sinubstitute natin yan, so I'll have C2 cosine beta x, then minus C2i sine beta x. So, y then would be equal to E alpha x. So, pwede na nating i-factor out yung pares na cosine. Magkakaroon tayo ng C1 plus C2, so times cosine beta x. Then plus C1i minus C2i times sine beta x. Kaya lang, C1 and C2, it's the same as another constant. This is another constant. So y then would be equal to e raised to alpha x C3 cosine beta x then plus C4 sine beta x. Or in short, y would be equal to C3 e alpha x cosine beta x plus C4 e alpha x sine beta x. So in short, so for imaginary roots or complex roots, not imaginary. So for complex roots, so y then is equals to, so palitan ko na lang yung C3 ng C1, no? So constant lang yon ng E alpha x cosine beta x. Tapos plus C2 E alpha x sine beta x. So yung kanina, so going back, so di ba ang solution natin is, so m is equals to negative 1 plus and minus 2i. Diba? So negative 1 plus and minus 2i. So from here, so we can identify that alpha is equals to negative 1 and then ang beta, so wag na natin consider yung sign, so which is 2. Okay, so alpha is negative 1, beta is 2. So ang solution natin nun, so would become, so C1 e raised to negative x cosine 2x then plus C2 e raised to negative x sine 2x. So this would be the answer. Okay? This would be the solution kapag ang roots mo are complex roots. So this would be our general formula sa complex roots natin. So dalawa na yung nadi-derive natin. So yung isa, distinct roots. Yung isa, complex roots. Questions? So kapag complex roots, so kunin mo lang. Ano yung roots na yon? Tapos identify the alpha. So ang alpha is, you have to consider the sign of the real part. Kung negative yan, negative. Kung positive, positive. Pero yung beta, laging positive ang beta. Okay? Kasi plus and minus yan eh. So, ang beta is always positive. Okay, next example. Last example. So what if I would have example number 3? Number 2 yun, no? So number 3 would be y double prime plus 4y prime plus 4y is equals to 0. So kamukha nung kanina, so m squared plus m or 4m tapos plus 4 is equals to 0. So ito pwede kong ma-factor out, no? So m and m was 2 and 2. So positive, positive. So what happens? So meron tayong m1, which is the same as m2, which is equals to 2. Ngayon, ang isang solution natin would be e raised to 2x. Okay? So pwede ba doon na ang y natin, ang general solution natin is c1 e raised to 2x? Okay, so supposedly that would be our solution. Kasi nga parehas yung roots is parehas na 2. Ang problema dito is there's only one solution. So hindi pwede yun. Since this is a second order, so dapat dalawa ang solution ng differential equation. So what are we going to do to resolve this case? Okay, so dapat dalawa ang solution natin. So gagawin natin, so we're going to employ yung reduction of order formula. Ang idea ng reduction of order, okay, so ang idea ng reduction of order, basta meron kang isang solution, ay tama, negative 2, sorry. Negative 2. Okay. So negative 2x, negative 2x. So reduction of order. So sa reduction of order, basta meron kang solution ng isa, pero alam mo na dalawa ang solution niya. Nakuha mo yung isa, so pwede kong kunin yung another solution. So using reduction of order. So in this case, ganito yung kaso natin. Meron tayong isang nakuhang solution, pero kailangan ko pa yung another solution. Okay? Kailangan ko pa yung another solution. So para maging dalawa yung solution ko. So to do that, so ang reduction of order, so ang ginagawa niya is nag-multiply siya ng one function. Okay? So nag-multiply siya ng isang function doon sa solution. Diba ang solution natin is e raised to negative 2x. So e raised to negative 2x. So ito yung solution natin. Y is equals to u of x multiplied it with e raised to negative 2x. Okay. So paano natin gagawin ito? Okay. So since ito na yung solution natin, y is equals to ux e raised to negative 2x, i-derive lang natin siya. So y prime would be derivative nito. So u dv e raised to negative 2x is negative 2 ux e raised to negative 2x. Tapos plus u prime of x e raised to negative 2x. Product formula. Yung y double prime natin, so that would be negative 2 times negative 2 would be 4 u of x. Okay, so 4 u of x. Tapos, e raised to negative 2x. And then I'll have negative 2 u prime of x e raised to negative 2x. Tapos yung pangalawang term, so plus, minus pa rin siya. So negative 2 u prime x e raised to negative 2x. Tapos plus u double prime x e negative 2x. So ang y double prime mo, so pwede ko silang i-combine. So 4 u of x e negative 2x minus 4 u prime of x e negative 2x and then plus u double prime of x e negative 2x. So mapapansin nyo, lahat ng term merong e raised to negative 2x, no? So balikan natin yung formula na yung equation natin. Y double prime plus 4 y prime plus 4y is equals to 0. So ngayon, substitute lang natin yon, no? I-factor out ko na yung e raised to negative 2x. Kasi lahat naman meron sila eh. So matitira would just be 4 u of x minus 4 u prime of x plus u double prime of x. Tapos plus 4y prime. So ang y prime natin is negative 2. So minus 4 times 2. So 8 u of x. And then so 4 times u prime. So plus 4 u prime of x. And then lastly, so plus 4 y is u of x. Is equal to 0. So ngayon, we have negative 4u prime, positive 4u prime. So 4 plus 4, 8 minus 8. So 4 plus 4 minus 8, 0. So matira would be e raised to negative 2x multiplied it with u double prime of x is equal to 0. So ngayon, we can now equate. So since product na siya ng exponential at saka ng second derivative of mu of x. So remember, ang solution natin, di ba, yung y is equals to u of x e raised to negative 2x. So meron tayo this time, u double prime of x is equals to 0. So, tapos, ang kailangan natin is u of x. Ang meron tayo, u double prime of x. So integrate mo both sides. So integral ng u double prime is u prime x. Integral ng 0, constant, c1. Di ba? Kasi derivative ng constant, 0. So integral ng 0, c1. Tapos integrate mo ulit. So this one would become u of x. So anong integral ng c1 with respect to x? So c1 of x plus c2. So ngayon, meron na tayong solution. That would be c1 of x plus c2 equals to e raised to negative 2x. So y then would be equal to c1 x e negative 2x plus c2 e raised to negative 2x. And that is our solution. So anong mapapansin nyo? So for repeated roots, so ang formula natin, okay, so for repeated roots, when m1 is equals to m2, so y would be equal to c1x e raised to m1x plus c2 e raised to m2x. Sir, paano kapag third derivative, higher order? Let's say tatlo pare-parehas. M1 is equals to M2 is equals to M3. So kapag ganyan yan, instead na U double prime yung makukuha mo, ang makukuha mo dyan, U triple prime of x is equals to 0. So mangyayari would be, so yung U double prime of x mo would be equal to C1. Ang U prime of x mo would become C1x plus C2. Ang U of x mo nun would become C1 x squared all over 2 plus C2x plus C3. Or simply C1 x squared plus C2x plus C3. So in short, magmumultiply lang tayo ng x. So C1, so x squared e raised to m1 x plus C2 x e raised to m1 or m2 x and plus C3 e raised to m3x. So in short, it follows na it only follows na kung 4 yan, mag-start ka sa x cube. Kung 5 roots na pare-parehas, mag-start ka sa x raised to the 4th. Pero yung roots niya pare-parehas lang kasi m1, m2, m3 are just the same. Diba? So, ito yung formula natin kapag repeated roots. Question. So, that is higher order. Sir, kailangan ko bang gawin yung mga solusyon na pagkahaba-haba na yan? Hindi. So, ang kailangan mo lang, hanapin mo yung roots. Okay? So ngayon, what I discussed now would just be some theory and how the formula were derived. Although di ko pa nagawa yung video, no, I'll try to finish it tonight. Examples ng mga homogeneous. So using shortcut, hindi na itong method na to. So these are just the formula. So para alam nyo lang, saan galing ang formula na yan? So bakit ganyan ang ginagawa ko? So instead of just using the roots. So basta repeated roots, nagmumultiply ka lang ng x. Tapos kapag complex roots, it's cosine and sine. Ang alpha mo, which is the real, tapos yung beta mo, yun yung sa imaginary. Tapos ang distinct roots, yun yung pinakamadali, yung distinct roots. So, kumusta naman? Schedule exam will be next week, 21 to 24. So same sked tayo sa major exam. No? Tapos pala on Thursday, so you'll have your quiz. Quiz sa Thursday. Although mag-upload din ako ng video para dun sa last topic. This topic is no longer included on your quiz. Ang quiz nyo will start dun sa homogeneous equation using substitution and then hanggang dun sa electric circuits. Ang exam nyo is divided into two parts, so part 1 and part 2. So yung part 1 is more on theory, 50 points. Okay? So there are 10 questions, multiple choice, 10 questions. This is theory. Or sometimes there are some equations. Okay? Baka mabigla kayo. Since that is theory-based, that is only 2 hours. Although that is available for 2 days. Okay? Pero ka-open nyo, magra-run na yung 2 hours. Okay? Basta in-open nyo, magra-run ng 2 hours. Then you have to finish it within that 2 hours. There are 10 questions there. So for the multiple choice. Ang coverage nun, it's the same coverage. So from homogeneous until the electric circuits. So more on, kung nakikinig kayo, naintindihan yung pinagsasabi ko dito, you'll be able to answer those things. Okay? Tapos yung second part, so ang activation nun, 2 days ulit. Kaya lang, you only have 24 hours to do it. Okay? So naka-activate siya ng Thursday until Saturday. Pero the moment na binuksan nyo, magra-run na yung 24 hours nyo. Okay? So there are 5 problems there. So bawat problem may 3 tanong. So 30 points each. So ang due niyan will all be, mag-open siya ng time natin sa Thursday, 10:10. Tapos magko-close siya ng Saturday, 10:10 din. So you have 2 days. So both parehas yung niya, time niya, it will be activated within 2 days. Kaya lang, yung part 1, so magra-run lang siya ng 2 hours. Ang part 2, magra-run siya ng 24 hours. Tapos pala, since i-input nyo yung mga sagot dyan, okay, so make sure. Kasi parang identification yung nakalagay dyan, ha? Pag mali yung decimal, kahit decimal lang yung mali, mali na yung sagot. Okay? So kaya dapat continuous calculation kayo. Nagra-round off lang kayo kapag susulat nyo na yung sagot. Okay? Or yung final answer. Pero along the way, so dapat buo yung ginagamit nyo. Okay? So usually, 2 decimal places, pag numerical answer, except dun sa pag pinapahanap yung value ng C or value ng K. Usually kasi pag maliit yon tapos decimal, so ginagawa ko up to 4 decimal places. So read the instruction. Naka-specify naman. So kung hindi in-specify, ilang decimal places, 2 decimal places ang gagamitin. Pero kapag naka-specify, let's say use 4 decimal places, so you have to write it 4 decimal places. Okay? So para tama yung sagot natin. Kasi right away after the end of the exam, you see your score. Okay? So lalabas na yung score nyo right away. Coverage ng quiz, dun sa methods of substitution. Start ka dun sa homogeneous. Dun sa homogeneous and linear in two variables. Tapos, until electric circuits. So, pag-hanapin mo yung K as is. Decimal huwag kayong maglagay ng ln. So, decimal. Tapos, kung 4 decimal places, 4 decimal places ang ilalagay. Other questions? I think yung problem solving, puro application. Okay. So good luck on Thursday. So don't forget don't forget to take the exam on Thursday. Sige, that's it. Yung examples pa nito, additional examples, doon na lang sa mga video. No? Kasi kasama yan sa midterm exam nyo. Although sa quiz, hindi ko na sinama. Pero sa major exam, kasama to. So additional examples will be posted on Canvas. Okay, so it's time already. Good day. Good day, good day.